Hello students, I am Sudarshan Kumar, your physics tutor. So we are studying current electricity. In previous class we had seen some few things of current electricity like definition of current and potential difference. Today we will see the expression of drift velocity. Okay. So firstly you should know what is drift velocity. It is the velocity of electrons after applying potential difference. Okay. It is the velocity of electron after applying potential difference. Its direction is in opposite of electric field. Okay. Or you can say its direction is opposite of current direction. Okay. So before deriving the expression of drift velocity, we need to know some parameters. Okay. So these parameters are: first, relaxation time. Relaxation time. It is denoted by tau. It is the time taken by the electron in successive two collision. Okay. Time taken by the electron in successive two collision is called relaxation time. The next thing is thermal velocity. It is denoted by U. It is the velocity of electron due to thermal energy. There are many electrons in conductor which are moving random because of this thermal velocity. Because electron achieve thermal energy from surrounding. Now that thermal energy is very low, but due to having very low mass of electron, this thermal velocity will be very high. This will be of around 10 to the power 4 meter per second. So you can see its thermal velocity magnitude is very high, but this velocity is in random direction, so its net displacement is zero. Okay, so its net thermal velocity average will be also zero, because average velocity is net displacement upon total time. So due to its random motion, net displacement is zero, so thermal velocity average will also zero. So you can write u average equals to 0. Okay. The third thing is, suppose this is a conductor. Okay. This conductor will have many free electrons. Suppose this is one of those, and when you apply a potential difference across it, their setup will be an electric field. Okay, there will be an electric field E, which will have this direction. Okay, because the direction of electric field will be positive from negative, positive to negative. Okay, so electric field will be in this direction. So when this electron experience this electric field, a force will act on this electron, and since this electron is negatively charged particle, so force will be in opposite direction of this electric field. So force will be in this direction. Okay, so you can write F equals to minus times of E into electric field. This minus sign here denotes that direction of force is opposite to the direction of electric field. Okay. You can also write force equals to mass into acceleration. So mass of electron me into acceleration equals to minus E into electric field. Here E is the charge on electron. You know, force equals to charge on electron into electric field. Okay, so A equals to minus E electric field upon me. Okay. So you can see after applying potential difference there will be an acceleration. Now despite of this acceleration this drift velocity will remain constant because due to this acceleration this electron will try to speed up their velocity. But again as it tries to speed up their velocity it will collide with another electron and its speed will get slowed down. So its speed remain constant. So you can say drift velocity is constant velocity, or you can say acceleration overall will be 0. So you can write acceleration overall equals to 0. So you can write Vd equals to constant. Okay. Now we will see the expression of drift velocity. You can also say drift velocity is the average velocity of this individual electron. So this individual electron will have individual velocity like v1 equals to, you will apply first equation of motion, that is v equals to u plus at. So v1 equals to u1 plus at1. Similarly v2 equals to u2 plus at2. Similarly, Vn equals to Un plus 8Tn. Okay. So drift velocity will be average of these velocity. So you can write Vd equals to V1 plus V2 plus V3 plus Vn upon n. So it will U1 plus At1 plus U2 plus At2 plus Un plus Atn upon n. You can break this into two parts. So Vd equals to, after breaking you will write U1, U2, U3, Un at here. Okay. So U2, U3, Un upon n, and if you take a common here then you can write T1 plus T2 plus Tn upon n. So you can write these are the average thermal velocity. Average of this thermal velocity, that is average thermal velocity, and we had seen average thermal velocity is 0. So this term will get 0, and these are the average of relaxation time. So this term will be called average relaxation time. Okay, you call it tau average. So we see Vd equals to A into tau average. Okay, and if you put A equals to minus E electric field upon Me here, then you will get Vd equals to minus E into electric field upon Me into tau average. Okay. So this drift velocity is in terms of electric field. You also know one formula, that is V equals to E into L. So from here you can write E equals to V by L. Okay. So when you put E equals to V by L in this formula, you will get Vd equals to minus E upon Me V upon L into tau average. So you can see drift velocity in terms of electric field and here drift velocity in terms of potential difference. So we have derived the expression of drift velocity in both terms, that is drift velocity in terms of electric field and drift velocity in terms of electric potential. Okay, thank you.